And good evening, everyone, from right across the province of Ontario. We have a great group tonight of 32, including Brian and myself, for OTF Connects, and we're going to be Makey Makey Makerspacing tonight and also talking about Raspberry Pi. And Brian Espinal is a great presenter, very well known to OTF and to lots of other people in the province of Ontario through various online and face-to-face opportunities, conferences, and that kind of thing. So Brian, I'm excited to be moderating your session again tonight. I'm going to turn off my mic and let you take over. So welcome to Brian.
Thank you very, very much. Let's do a quick green check mark if my audio is good, and a red X if I'm way too loud or you just want me to stop talking already. And it's really funny when I say those things because you get a few chuckles in the chat box like Susan right there, but I probably got half of you doing a massive eye roll as well, which is totally acceptable. I'm here to entertain just my dog. He's the only one in the room that can actually hear me, and really the only one who actually responds to the ridiculous things I say. So these are always interesting to talk to a screen, so I encourage you to throw tweets at me, talk in the chat box. I will pause every once in a while and get on that chat box just to make sure we're not missing anything there, but it's worked best in my experience with me shouting at a screen and having folks chat back at me so we can kind of keep things going sort of almost in parallel. So we're going to talk about Makey Makey and a little bit of Raspberry Pi stuff today. But before we do that, I always like to talk about why it's so incredibly important. Computational thinking is a term that's actually been around for about 30 or 40 years. And it's since reared its head again, I guess, in the last decade or so. Jeanette Ling made reference to this term in about 2006, talking about computational thinking and how it will be in every aspect of our community, you know, in the near future. And it's not just about coding. It's not just about, you know, playing with Minecraft, but it's using the power of technology and giving kids an opportunity to explore their passions and really pulling what they can do with technology to solve problems in their everyday lives by whether it be app smashing or using Makey Makey or a Raspberry Pi or coding or making a green screen, anything like that. There is a incredible overlap between computational thinking and mathematical thinking. You know, with all this focus we have here in Ontario about math and numeracy and asking better questions, there's a great entry point into the computational thinking world. And like I said, it's not just about coding. Coding is a piece of that computational thinking umbrella, but so is making on Minecraft, and so is playing on green screen or making iMovies or things like that. So I've been tweeting this out the last little while. Matt, your mic's on again. I've been tweeting this, and that's okay, Matt. By all means, that's okay. No worries at all. So anyway, this graphic it really shows the overlap between the mathematical thinking and the computational thinking, and you know how they support each other. So I hope to provide you some examples tonight of computational thinking using a makerspace with a little bit of coding to support our students in their numeracy. This started long before me, and will continue very, very quickly in the very near future. I came across this stat about 3 weeks ago, and it really made me think that in the next 3 or 4 years, we'll see more things connected to the internet than people. And that means your fridge will tell you when the water filter is dirty. It means your stove will text your phone when the oven is at temperature. And it means for the first time in history, we are going to have more vehicles connected to the internet than not. It is definitely a maker movement. We live in a world where people are 3D printing out of the basement of their own house. We have a significant influx in entrepreneurs and people selling products that they're making out of their house via the internet and through social media. And that leads me to Eric and Jay. So Eric and Jay invented the Makey Makey, and they were students at MIT. And They believe that everyone is creative, inventive, and imaginative, and that really supports what we call the 21st century skills in education today. Eric and Jay believe that everyone can create the future and change the world, so they've dedicated their lives to making easy-to-use invention kits. But we do have to back it up a little bit, because Seymour Papert really started this movement in the 80s, 90s, and early 2000s, and he believed that students should construct their own knowledge of the world. If students are going to be active learners, they have to learn by doing. And so he believed, for example, if we wanted students to learn about perimeter, he wanted them to walk the space on the floor, whether it be trace a shape on the floor or walk around the room. He wanted students to actually construct their own knowledge by doing perimeter in the physical classroom. And so he invented Logo, which was one of those first block-based coding languages in the 80s that allowed students to actually program a turtle to move around the screen. Now today we have Mitch Resnick, who also works at MIT, and based on Seymour Papert's work with Logo at MIT, Mitch Resnick is the face behind the Scratch movement. And a lot of people don't realize that Scratch is actually over a decade old, and they've been pushing the 4 Ps for over a decade: peers, passion, projects, and play, which I think is a little bit humorous. We talk about 6 Cs in Ontario today in 21st century skills, and Scratch and Mitch have been saying this for well over a decade. Papert believed that students would construct their own knowledge of mathematics, and they lived in a world that he called Mathland. And so Papert said, you know, if you tour a country like France, you're going to learn the French language by immersing yourself in it. And if we can immerse our students into what he coined as Mathland, then they will all become mathematicians and have a love for numbers and mathematics. So this brings us to our first video. If you have a mobile device, you're welcome to scan the QR code. Susan will likely throw the link to the video in the chat box. It's a very quick link. I'm going to clear all the check marks, and when you have finished watching the video, if you could come back and hit that green check mark, then we will all know when everybody is ready. So I'll give you about a minute or so. Check out the video. It's 30 years old, and when you're finished, come back and hit the green check mark. I'm going to mute my mic, and that's just so you don't have me breathing on top of your video. So go ahead. So we're just waiting for about 9 more. It never ceases to amaze me how ahead of his time Papert was when he talks about authentic mathematics and making kids doers of mathematics instead of just doing mathematics. So a lot of credit to him, who really started this coding movement, this computational thinking movement well before I was a teacher. So much respect from my part. Okay, I'm going to continue. We only have about 5 or 6 just waiting for us now. So back to Eric and Jay. They wanted to invent a Makey Makey invention kit that would work on Scratch. So if you think about Papert, who developed Logo, and then Mitch Resnick, who him and his team developed Scratch based on Logo, Eric and Jay wanted to bring Scratch and Logo into the physical space by creating this sort of breadboard where you could interact with the digital content in the physical world. So they pitched on Kickstarter, because that's the world that we live in. They tried to crowdfund this breadboard, and it absolutely went viral. So another video, this kind of a workshop that I do with Makey Makey, of course, is meant to be incredibly hands-on, and because I can't do a live demonstration with limited bandwidth, we're going to have a little bit more video than you might be used to in a session, so I apologize for that, but that was the only workaround that I could see. So this video is the pitch video that Eric and Jay did on Kickstarter when it was just an idea, when it was just in conception, and they threw it out to the internet world and said, what do you think of this? It's only about 2 minutes long, so again, I'm going to hit the clear and get rid of all those check marks. If you could please hit the green check mark when this video is finished, I'm going to mute my microphone again. So the internet loves these kinds of projects, and they raised $500,000 to actually bring this thing to life, and it's awesome. It's absolutely amazing. I love all of the Makey Makeys that we have. We use them as tools in our Makerspace when kids want to use them to interact with things. I've had students just this past Christmas who coded little applications to play Christmas carols, and they had Makey Makeys hidden in the Christmas tree in the front foyer, which was super cool. Kids could, and staff actually, the staff I think were more engaged a lot of the time. Touching ornaments on the Christmas tree would trigger sound effects. The Christmas tree came to life because these students had coded this soundboard in the Christmas tree, which I thought was absolutely amazing. So let's talk about what this thing actually is. It really is a simple idea. It's a keyboard interface that allows you to connect physical objects to your computer, and as far as the computer is concerned, you are only touching the keyboard. So in the Scratch environment, when you use certain keystrokes as triggers, the Makey Makey is just replicating those keystrokes. But it adds an additional layer of engagement and richness to the task, because students are taking Scratch and building it into the physical space and thinking about that. You know, that's the spatial reasoning piece and looking at the big picture. But they're also inquiring about what a connector is. So really, it's the medium, the interface between the user and the keyboard, which makes the computer think you're actually just touching keystrokes. And why is that super cool and super important today? Well, who doesn't want to play the piano scene from the movie Big? When I first saw this Makey Makey, I thought, that is what I have to do. We have to put a giant piano on the floor. So I jumped on the internet and I wanted to see if projects already exist, because you can extend the wires on the Makey Makey using speaker wire, and you can make the circuits as small or as large as you want. In the classroom, you can use bare conductive paint if you want. Anything that's a conductor can be connected to a Makey Makey. So I jumped on the internet and I realized we live in a world now where kids will create content without being asked to do so if they are interested in it. And let me give you another example. This student is from YouTube. I've never met this individual, but I always cite this person. This student wanted to try the piano. So I'll give you about 30 seconds again. Have a look at what he did in his living room with his parents. It's a super cool project, recreating the piano on the floor in the classroom. I'm going to mute my microphone. I'm going to clear all the arrows again. I will see you in 40 seconds. I love the problem solving, determination, resiliency, you know, the learning skills that we really focus on, or we should focus on in Ontario. I've said this before and I'll say it again. You can look at the front page of an Ontario report card and you can predict the marks on the inside. If a student has E's and G's in their learning skills, you know their A's and B's, and there's a correlation there. So maybe if we focused on those soft skills, the grades, you know, the scores, if you will, would also improve. Just going through, trying to get caught up on the chat box. In terms of where to order these from and how much they are, I will take you to the official spot on the Makey Makey website and show you where you can get those there. They do also ship out of Toronto, as well as Erica's question about how many Makey Makeys would I suggest, or would anybody suggest. I think it all depends on the task. If you wanted them to be, you know, a tool in the belt, then you would probably only need a couple. If you wanted to do something, it really depends. If you wanted to do something class-wide, I don't know if you would want 1-to-1 or 1-to-2. We have a box. We have about 30 or 40, but at any given time, I think only 5 or 6 are being used. And that's just because of the nature of our pedagogy in the community at our school. It's the students use the Makey Makey if they see it as a solution to a task or problem that they have been challenged with, rather than me saying, okay, we're all going to create with Makey Makey today. So we sort of rethought our practice at our school, and bought way too many at the beginning and now realize that instead of that sort of one-size-fits-all, hey, everybody, let's do this really cool project, which, I mean, you have to do from the get-go anyway to expose these kids to it. But after that, using it as a tool in the belt, I would think a half a dozen is definitely more than enough. So again, I apologize for the video, but like I said, this is meant to, it's a makerspace, right? It's meant to be hands-on. So let's jump to a video on how to actually connect a Makey Makey to a computer using a USB port. So I will clear the check marks yet again and see you in 2 minutes. I always love choosing that video for a variety of reasons, mainly because they troubleshoot and they didn't bother to edit it out. I think it's really important to model that risk-taking and that failure in the moment and stumbling through the problem. In that particular case, the issue is not the Makey Makey at all. It's the objects that they were trying to interact with, not the best conductors. And I know they don't make reference to that in the video, but still a great video to show somebody connecting a Makey Makey, because you are going to run into problems the first time through, I promise. At this point, we're about a half an hour in. If there are any questions, happily raise your hand right now or tell me to slow down, or if anybody feels lost, want to make sure everybody's on the same page before we actually jump into building something. So there's a question from Sarah. If you want to use a microphone or chat in the box, by all means, go ahead. The question is, what math do you teach prior to using the Makey Makey? I personally love the Makey Makey to engage in applications that I've had students create on the computer or code on the computer, or ones that they've actually found before. I use it, I try my best to use it to have kids do something they couldn't otherwise do without it. Because it really is a keyboard interface, I want them to use it in a way that you couldn't use with a keyboard. And I'll give you an example. I had students code a countdown timer for a gym activity, actually, for phys ed. And so this countdown timer, when you started the app, it would count down from a minute. And the students had put tinfoil at either end of the hallway, and they had run speaker wire down the hallway of the school. And so the idea was, when you touched the tinfoil at the starting line, the countdown timer would start, and the students would sprint to the other end of the hallway and touch the other piece of tinfoil, which would then stop the timer. The reason we needed the Makey Makey, you couldn't extend the keyboard down the hallway, so the start line and the finish line were both wired with speaker wire to a Makey Makey that was plugged into a computer, and the application was actually running on the computer. And I know that may not be the best math example, it was a phys ed example, but those are the kinds of things I try to get my kids to do with them, something they couldn't otherwise do without it. I don't want it to replace anything we already have. I want it to be something that they weren't able to do without actually having it. Next question, Amit, do you want to use microphone, or feel free to type into the chat box? Do all the banana wires come with the Makey Makey, or do you have to purchase them separately? The Makey Makey comes with, I believe it's 6 alligator clips. I'm going to show you the order website after, and it shows everything listed with it. It comes with 6 alligator clips, and it also comes with 6 shorter wires because there's other inputs on the back. So the idea is, you purchase the Makey Makey, it comes in the mail, out of the box, you can make the banana piano. Mark?
Hi, Brian. Can you hear me?
Yes, go ahead.
All right. I just wanted to know if there's any particular websites that the Makey Makey is best suited for, because I've seen things like Pac-Man games.
Great question. So any online games that can be played on the keyboard can be used with the Makey Makey, and that's what I love about it too. If you teach younger grades or students are not coding apps or whatever, any application or any game or anything on the computer that can be controlled by the keyboard can also be controlled by the Makey Makey. The only limitation is, by default, the Makey Makey has certain keystrokes. So it's up, down, left, right, space, left click, WASDF. You can change those keystrokes, but out of the box, those are the only keys that the Makey Makey will actually communicate with on the keyboard. There is a way to reprogram a Makey Makey so different keys actually work on it, but you are limited to those inputs. So I know that they really use the banana piano as a promotional tool. You can't actually create a full-scale piano. There's not enough inputs on the Makey Makey to do that. But any Pac-Man or the Makey Makey built-in piano apps, they all work great, and I'm actually going to share those in the next couple of slides as well. Any more questions? Going once, going twice? I'm pretending I'm staring at an audience and everybody's nodding like, let's move on. Erica says, how have the Makey Makey held up with frequent use? They're actually very, very durable. Our students, chuck them into a box when they're done. They're pretty hardy. I actually haven't had one break yet. I haven't had one fry yet. I've been using them for about 2 years as well. So very, very durable. Okay, before we go any further, you are all very smart people, probably smarter than I am, so let's talk about curriculum connections. I use the Makey Makey to do things in my math program I couldn't otherwise do without it, as well as some phys ed. We've used it to create some interactive bulletin boards to sort of bring bulletin boards to life. But what curriculum connections can you make? So we'll spend about 30 seconds to a minute. If you want to use the text tool, please do so. We can all share on this space. So if you grab the text tool and type onto this slide, we will all see it, and it will all be recorded so that we can access it afterwards. Farah says mapping skills, so I'm going to go ahead and write that. Mapping skills. Don't be shy. Let's say composing music. I've had students build a piano app and then compose music on it for the music teacher. Music for sure. Could you set it up so that you walked across something, it would graph the motion? Absolutely, absolutely. It would all depend on the surface that was being walked on. So on the surface, I would have different pieces of tinfoil that are not touching each other, and each piece of tinfoil would trigger that movement, almost like you're walking across kind of a bridge, if you will, where each board is isolated. As long as they're not touching, because you can't cross the circuits, then you could absolutely do something like that. Representations, use of strategies to solve problems, for sure. For sure. I take a lot of anecdotal notes in our makerspaces, and really focus on our learning skills in those environments. And I do my best to try and pull the curriculum out of the activities that the kids are doing when they're in their passion projects or their Genius Hour projects. I really think it's important that I go and extract the math from it and have those authentic conversations. Geometry building with shapes, definitely. Definitely. Interactive art, I love that idea. I love that concept. It was a student's idea of mine to create an interactive bulletin board. We had a piece of tinfoil on the floor, and when you stood on the tinfoil and you touched parts of the bulletin board, you heard audio clips and different things happened because it was all connected to a Makey Makey and connected to a Chromebook that was just sitting beside. I actually pranked my class. I connected a Makey Makey to the door handle of the classroom, so when they tried to open the door, it played really scary sounds at Halloween. Kim's asking if we can explain the geometry building with shapes. So who wrote? Farah wrote. Is it Farah? Geometry building with shapes. Can you explain that? Either in the chat or on the microphone. I'm interested in that one as well. I have a hunch, I'm going to go out and say, okay, when we ask students to build structures, they can do that. That's sort of what I was thinking. If a student had to build a two-dimensional shape using physical pieces. Maybe you took a coat hanger and cut up a coat hanger to pieces if they built a square. Maybe an LED light would turn on, implying that the circuit's been closed, but you could only build the shape in a certain way with the tools that were provided. Yeah, sorry, Lisa, I noticed that as well. Hopefully it's just a bandwidth issue and you'll be able to stay on, or at the very least, check it out tomorrow. Lots of good stuff there. That'll be saved on the video so that we can refer back to it. Like somebody had said, by default, grade 6 circuits, by default, design and build series and parallel circuits, draw labeled diagrams. It's really neat to have one student hold an alligator clip connected to a Makey Makey and have every student in the classroom hold hands, and the last student would then ground themselves on the Makey Makey, and the entire class could make something come to life or close a circuit and make lights flash. It's really, I think, it's that kinesthetic activity that a lot of our kids need. Also, the math process at the beginning of every grade here in Ontario, I don't think we spend enough attention on the math process as we do on specific expectations, but you know, it says computational strategies in our math document. We often talk about how old our math document is, but it's a great document, and our interpretation of what's already written just needs to change. Problem solving's been in there for a decade, reasoning, improving, reflecting, selecting tools, computational strategies, connecting, representing, and communicating are all things that can be done with the Makey Makey. Obviously, inquiry, what is a conductor? What would happen if I change this variable? What observations can I make? Just watching students try and close circuits and troubleshoot and solve problems and feed off each other, and all of those activities that come with something that's rich and open-ended is incredibly powerful. And I love watching students try and fail in a process with the Makey Makey, because it does provide them with immediate feedback. They know in the moment whether their application or whatever they're building is working or not. They don't need me to come by and tell me they have it right, because they see the results immediately, and if something's not working, then you know they're seeking out the other experts in the room, and it's just a really rich, loud, powerful environment. And definitely the spatial reasoning piece that Farah has mentioned in the chat box, being able to see that big picture, and you know, like a good chess player, being able to see 3 or 4 steps ahead in a game of chess, and being able to use the Makey Makey and other tangibles with it to do some really, really neat things. So I just want to share a couple of student projects that we've done. The top left is a Makey Makey drum kit connected to tin foil drum sticks that are connected to wires. Sitting on a piece of plywood, and when you actually play the physical drums, it plays the digital drums on the computer. The top left is a water piano connected to Makey Makey alligator clips that are actually sitting in beakers of water. The bottom left is a carrot piano, and the bottom right is a super cool project. It was this student's idea. He loved Dance Dance Revolution and said, "I've found Dance Dance Revolution on Scratch. I'm going to remix it. I'm going to connect it to my arrow keys, and we are going to play Dance Dance Revolution in the hallway. I'm going to put tinfoil on the floor. I'm going to connect it to the Makey Makey, and you have to touch the appropriate piece of tinfoil as the arrows come scrolling down." So I'll give you 5 or 10 minutes. Each video is no more than a minute, but I know that there's 4 of them. Just take a quick peek at some of the maker projects that we've done at our school. Hit the green arrow, sorry, the green check mark once again in about 5, 7, 10 minutes, somewhere along those lines. I'm going to mute my mic again. Okay, we have 28 of 37 green check marks. I'm sure other people are around and maybe have just not hit that check mark yet. I haven't seen one in a few seconds, so I thought maybe that we could advance. I wanted to build an app. I thought this is always meant to be hands-on, so let's build something we couldn't do without. And so traditionally, I have always taught intermediate probability by having kids flip coins and play with spinners and roll dice, of course, and have them mark in T-charts the outcomes. A few years back, a student came to me and said, I'm going to code you a coin flipper. And I thought, okay, if you can pull this thing off, this is going to be really, really cool. And it turns out that it actually wasn't super challenging, but kudos to him for coming up with the idea. And so he coded a coin flipper that I now use to teach probability and the law of large numbers really fast, because I can run his simulator and I can flip a coin 1,000,000 times in a few hours, and they get to see that it's 50-50. So I want to build a quick coin flipper app, and then I'll show you a video that I recorded of myself connecting the Makey Makey to the coin flipper, just to give you an idea of how you can use a Makey Makey to flip a digital probability simulator. So I'm going to try and do a screen share. And as I'm doing that, just looking at the chat box, when do they play the piano? Sorry, when they do the piano, are they using the back? They are using the back of the Makey Makey because of the additional inputs that are listed there, yes. Google Chrome is where we're going to go. And Scratch. If you are on a mobile device, unfortunately you're not going to be able to dabble with us in the Scratch environment because it is Flash-based. But just so I know, can somebody raise your hand, give me a green check mark, yell at me, whatever. Let me know that you can, in fact, see my Chrome web browser. Green check mark, perfect. I see a bunch. Okay, so if you want to follow along, open your web browser and hit scratch.mit.edu. You don't need an account unless you wish to save this project, but we're going to actually click on the Create button that's up in the top left near the Scratch logo. And it will bring us to the Scratch interface. Supposed to bring us to the Scratch interface. There we go. Okay. Does everybody see the Scratch interface? I apologize for having to go back to the green check mark, but under the circumstances, do we see the cat? Great. Okay. So this is Scratch. It allows us to do some really cool block-based programming so kids don't have to understand syntax. They can link code together and not have to worry about missing colons or things like that because the code is already built in. So everything in the Scratch environment is event-driven, just like everything we do with technology is event-driven. You don't log into Facebook until you hit that login button or actually open the app. Nothing happens without human interaction. So in order to get started, we're going to head over to the events section, and we're going to use a when green flag clicked. And the green flag right here is just going to tell our application to start. So in this example, the green flag is going to tell the application to run and tell us we're ready to actually flip a coin. Okay, so I want to delete the cat, and that's, you just right click on the cat sprite itself, and you'll notice delete in the pop-up window. I'm going to delete the cat, and I'm going to quickly make a couple of simple sprites just to show you a coin flipper. So I'm going to actually paint a new sprite, which is located in the middle towards the bottom where it says new sprite. Hit the paintbrush, and I'm going to hit the text tool, and I'm going to put an H, like so. I'm going to see if I can actually make it significantly bigger, like that. And you'll notice it's in the middle of my screen. Perfect. I'm going to now right-click on the H. I'm going to hit duplicate. And I'm just going to actually erase it now. I should have just hit new costume instead of doing it this way, but however, Now I'm going to make a T, and this is just for heads or tails. And I'm going to try and plunk it sort of in the middle as well. You'll notice when I go back between H and T that the alignment is off significantly. Scratch is a little finicky like that. There's a few tools you can use to try and align it back. Actually, I believe there's something up here that will center it or show us where the center is. If I do that, I just make things worse. So ignore what I'm doing. Try your best to make the two sprites. It's okay if they're not over top of each other directly. There we go. That's pretty close. You see a heads and you see a tails there. And I'm going to head back over to script. So what we've done is we've created a sprite, and the sprite has two costumes. And I'm going to have this application randomly choose a number between 0 and 1. And if it randomly picks a 0, I want it to show, say, the T. And if it picks a 1, I want it to show the H. And then I want to sort of create a tally in order to do that. So I'm going to create, under data, I'm going to make a variable. And I love using Scratch because it really does allow you to spiral your math strands. I mean, making a variable now, I get to talk about science and I get to talk about algebra while we're actually making this really cool thing for probability. So I'm going to make a variable and I'm going to call it flip. And I'm going to hit OK. And you'll notice some new commands appeared in the middle of the screen. And I'm going to drag the set flip to 0 out to my control panel here on the right side of the page. Okay. If I am going too fast, because I don't actually see Blackboard, feel free to hammer on the raise your hand tool because it does ping the sound, so I will hear that I'm going incredibly fast. Okay. So set flip. We're going to head over to operators. Operators is where all our really cool math functions exist in the Scratch environment. And I'm going to use pick random. And I'm going to drag random out. And I'm going to change pick random from 1 to 10 to pick random from 0 to 1. And I'm going to take this now and I'm going to plunk it into where the 0 is. And you'll notice it highlights, implying that it does in fact want to fit and go in there. So now I've got a flip command that's going to pick a random number between 0 and 1. And I'm going to head back over to events. And I'm going to take a when space key pressed, and I'm going to plunk it out there. And you'll notice that my flip variable showed up on the screen. It says 0 right now, but every time I press space, you see flip is 1, 0, 1, 1, 0, 1. I hope you can hear the keystroke, 1, 1, 1, 0. So it is in fact working, but I wanted to actually change the costume so we have a little bit of a better visual. So in order to do that, we're going to head over to control and we're going to use an if statement. So pull an if statement over. Actually pull two if statements over. What we want is if the random number 0 is picked, show a T. If the random number 1 is picked, show an H. So in this example, let's use two ifs. We could use an if else, but that's okay. We'll just use the two ifs. And head back over to operators and grab your equal sign. And you can actually just plunk it right in there. You'll notice the shape is the same. It's the hexagon, and it does highlight in white, implying that the equal sign does fit. So plunk two of them in there, like so. And then you're going to head to data. You're going to grab your flip variable. And you're going to actually put it into the first white box of both of those, like so.
I just lost your screen, Brian. Okay, so it's back. Yep.
How about now? Sorry, every once in a while I do the Alt-Tab to hit Blackboard so I can see the chat box, but I forget that when I leave that active window, you just see a black screen. So if you do see the black screen, it just means I've gone back to Blackboard because I was checking up on the chat box. But actually, I should be able to just move it over. Make room for both. Okay. So if flip equals, and then use your keyboard, 0, and underneath, 1. If flip equals 0, then, and if flip equals 1, then. We're going to head over to looks, and we're going to use the switch to costume. And if flip is 0, I want it to be costume 1. And if flip is 1, I want it to be costume 2. And you remember under costumes, costume 1 is the H, and costume 2 is the T. So now, when I hit the space key, you should see flip change from 0 to 1, but you should also see the appropriate letter. So here I go on my space key. How about I hit the green flag first and try again? So when it's 0, it's H. When it's 1, it's T. And it is picking that at random. Good thing it's 50-50 in this example that I'm showing you every time I hit it. So the idea now is we've created a simple application that'll flip a coin, and we can now connect that to a Makey Makey, and we can have students find objects in the classroom that are conductors and see if they can use those objects to actually trigger the coin flip. You could take this, you could extend this and take it one step further. I've had students tally, so they've recorded the number of heads and the number of tails actually in this application. So it's actually spit out the experimental probability, which has been something that's super cool. Won't bother with it today because we are focusing on Makey Makey and not Scratch. So having shown you that, I'm going to switch back to Blackboard and fire up the video of me connecting my Makey Makey to an existing coin flipping app that I've created so you can get an idea of what that looks like. So you will see a black box right now, and you should now see placeholder screen share slide. This is the coin flipper that we created, actually that my students created. They had created a turbo button. And what the turbo button does is he took all of his code and he threw it into a loop. And it flips this loony really fast, but it prompts the user for the number of flips. And he actually had it record heads and recorded tails, and he had it record the percentage of heads and percentage of tails. It was really powerful to hit that turbo button, to put in 1,000, watch this coin flip 1,000 times, and actually watch these numbers get closer to 50-50. Like, to see the law of large numbers happening on my smartboard from an app that a kid had built was super, super cool. So there's the link to that. If you want to check it out later, I won't spend any time on it today. Here's the video of how to connect the Makey Makey to the coin flipper app, just to give you an idea of how we use it in my math classroom. Susan's posted the link, so I will see you in 51 seconds. Apologies, that's the Scratch link. There is the YouTube link to the video with connecting to the coin flipper. One of the things I love the most about Makey Makey is not just having kids create math content with the Makey Makey, but because it's math by default, using math to create other cool content. I've had students code choose your own adventure stories connected to a Makey Makey, and I got to interact in the physical space by touching objects to choose what the main character in the story did. Really powerful stuff, really deep, rich, that abstract thinking. So all math by default. I know I'm showing you some math examples, but It's all math, and using the math in it to do things in other subject areas. Great science example, coding the particle theory and having students touch physical objects in the classroom to show what solid particles look like, what liquid particles look like, and the movement of gas particles. And you can touch those 3 buttons that you create in the classroom to show the results on the screen. Really cool stuff. You don't have to code by any means to get started with Makey Makey. They've actually created their own built-in apps. So I wanted to just show you quickly the built-in Makey Makey piano. They also have a drum kit. And you can actually Google Makey Makey apps, and a whole bunch of these will come up. I did record a video of connecting to the Makey Makey drum kit, so I wanted to share that with you as well, because this is something you can do right out of the box. So if you purchase a Makey Makey and you get it, open the box, everything you see in this next video you can do in a matter of seconds. So again, I'm going to mute my mic, and I will see you all in about 35 seconds. Okay, I think just about everyone is back. So I'm not going to do a screen share on this one, but grab this link, make note of this link. There's a wealth of information that Makey Makey has put together, including lesson plans on how to get started on some of these really cool activities. So copy that link or scan that QR code. Highly recommend checking it out. Everything listed on that page can be done by all ages and in all of our elementary schools using stuff that you would find in your house and stuff that you would actually find in your classroom and in your school on a regular basis. If you are still have not purchased and want to purchase a Makey Makey, you can get it right from makeymакey.com. It does come with everything that was in that video. That what I just recorded there was right out of the box. The USB cable, the alligator clips for the front. The 6 connector wires are for the back, for the more advanced input. Also comes with some really cool stickers, and the graphic instructions will actually show you how to do the banana piano right out of the box. So makeymакey.com, $50 plus shipping. So like I said, you want to purchase 3 or 4, couple $100, and you are off and running if you want to have a little center. Now, the Makey Makey Go was successfully kickstarted this past fall. They wanted to make a smaller mobile version, and they called it the Makey Makey Go, and it was very successful on Kickstarter, so they have actually brought this product to life. It is half the price, but it is very limited on what it can do. It's got the single alligator clip, and it's got a play button. So essentially, I think they're targeting it. They're marketing really young students who want to just push one button in the physical space and have something happen on the computer. There's only one input. And to my knowledge, you don't actually have to close a circuit. It's just one wire connected to that object. If you can see the rightmost picture with the banana, there's no circuit here. It's an alligator clip to a banana, and then touching the banana actually has something happen on the screen. So that is an option for $25, again, plus shipping. So design challenge time. What lessons can you create using the Makey Makey, whether it be interactive bulletin boards, whether it be inquiring about conductors? Grab the text tool, let's spend about 30 seconds and just sort of brainstorm some super cool ideas, because I always love learning from the audience. I always have somebody throwing something at me that I've never thought of, which is incredibly important for my own professional learning and my own reflections. So please spend 30 seconds, grab that text tool, and fire off your first idea. What are you going to run back and do with the Makey Makey when you get one? Oh, I love the dance idea. I'm not an arts teacher, so that wouldn't have been something on my radar, but I can certainly see how that fits very well. Music lessons, definitely. Composition, but actually creating the instrument too, which is kind of neat. Have students, you could have students actually make a guitar. The guitar strings could be speaker wire. They wouldn't have to strum them necessarily, but touching them would close a circuit. Interactive math game, definitely. I always think of Guitar Hero and Dance Dance Revolution for some reason every time I see a Makey Makey activity. I like the interactive word problems, bringing it into the language program. Inventing a sport, Simon says, definitely. I've had older students make their own instruments, but we didn't have to loop in circuits as well, so super cool. Yeah, again, it's that added layer, right? If I think of it, I picture it as cake layers, and the more layers we have, the richer that challenge is, or that task is. Okay, those are all going to be saved. Some very good ideas there. Let's quickly chat about the Raspberry Pi, because I know that we had talked about it. So the Raspberry Pi is a microcomputer, but it comes loaded with Scratch. So you can do some really cool things with the Raspberry Pi connected to a Makey Makey, just bringing it to that next level. And the Raspberry Pi 3 has just come out. There's a whole slew of Raspberry Pi options actually available nowadays. I did, of course, record a quick video of my Raspberry Pi 2. It's not very long, but just a quick overview of what the Raspberry Pi 2 actually is. And then we'll come back together in about a minute and a half. Okay, we're getting close to the end. I just have two projects I wanted to share with the Raspberry Pi. It is a pretty advanced piece of hardware, something I dabble in if kids are really interested, and again, these are generally grade 7 and 8 students. If they've taken an interest in coding in Makey Makey, then we'll explore the Raspberry Pi. I don't use the Raspberry Pi as a programming environment in Scratch just because we still have desktops and laptop computers, so we just kind of jump on there. But we do try and use the Raspberry Pi to create some really cool things that I haven't seen before, including the Magic Mirror project, which really started about 2 years ago. Massive, massive game-changing project. I absolutely love this thing. I'm dying to do it at my house. I haven't done it yet. I forget the gentleman's name. He was walking with his girlfriend in the mall a few years back, and he saw this interactive panel, and he thought, that is really cool. I'm going to build that. And I think about the skills we try and teach to our students. And so this gentleman walking through the mall saw an interactive display and said, I can do that. I can do that using Raspberry Pi and my skill set. So what he did, he took a two-way mirror, so an observation mirror that you would see at a police station, and he mounted a monitor behind it so that looking at the mirror, you could see the image that was on the monitor, but nothing else. He connected a Raspberry Pi to this monitor. He wrote some custom software, and he made it play in full screen. And so when you actually look at the mirror when you're getting ready in the morning, he had coded some apps and some widgets to actually display on that monitor. So as he's doing his hair in the morning, he gets the news updates, he gets sports scores, he gets the weather. Absolutely incredibly cool idea, product he's created. There's actually a Magic Mirror section now on the Raspberry Pi website because it's become pretty cool project. I had a few students show me that one actually a few years back, and I thought we actually have to try this thing. And I haven't been able to find a one-way mirror yet. So if you know anybody who's got a one-way mirror, let me know, because I would have my Twitter feed, I would have my sports scores, I would have my weather and everything rolling on it in the morning, and I think that would just be absolutely cool. Wanted to share one final project before I show you the Raspberry Pi lessons page. This person made a soundboard connected to a Makey Makey and connected to a Raspberry Pi. So each one of those bronze objects you see on the screen, when you touch them, you hear a different sound. So check that out. It's very quick. I'll see you in about 30 seconds. I love that one. I love that, the whole thing about that project and creating that soundboard. And I don't know what he coded it in. Could have been Scratch. I have no idea what he used, but Makey Makey connected to the Raspberry Pi. Super cool project. There are some teacher resources on the Raspberry Pi page if you do have Raspberry Pi or access to Raspberry Pi, or you do want to explore some of the things that they've got going on there. Feel free to grab that link, throw it in bookmarks, have a look at that at a later date. Just before we wrap up, I'm going to do one shameless plug, and that's only because I really truly believe in the soft skills and focusing on learning skills and what we do here in Ontario and all the really cool things that are happening. So I wanted to share Admetal as a way to assess your Makerspace, your Makey Makey projects, your Raspberry Pi projects. I've been working on Admetal for a little over a year. It's a place where students and teachers can endorse each other when they are seen demonstrated our learning skills in a positive manner. It's sort of that positive reinforcement approach. We do a lot of Rotary at my school, and my job as a homeroom teacher is to actually write learning skills, and you know how busy teachers can be. I don't always know what little Johnny is doing, and perhaps little Johnny has a bus buddy, and he demonstrates initiative because he's always going to get his bus buddy 2 minutes before the bell. And I don't know about these things, but maybe his friends do. And so under the Admetal platform, little Johnny's friends can go and endorse him for some of those soft skills, because our kids see a lot of the things that we don't always see, and it's a place for our Rotary teachers to actually have a voice to help us out with our own learning skills in our homerooms as well. So you can download the feedback at the end. I use Admetal as a place to capture the really cool things we're doing with Makey Makeys when I see kids demonstrating resiliency and perseverance and grit and things like that. I can go on, I can give them a badge. Mom gets an email that says, little Johnny did a great job with resiliency today. Here's what little Johnny did. It's all saved in one place, and I can actually have other members of my school, students and staff actually participate in writing learning skills because everybody has a voice in the Admetal platform. On that note, we have 2 minutes for feedback. Susan?
So there's a couple of questions in the chat, and I'll let you either respond. If you want to respond in the chat, then I can go ahead with the feedback part of it. And then we can turn the mic back to you again if there's a couple of things to say. But thank you, Brian, for a great session. I really love the combination of watching videos and then coming in and seeing your screen and doing a demo. It all just worked out really smoothly. Lots of great learning, such exciting ideas for all of us. For all of you that participated tonight, great, huge group tonight, and lots of enthusiasm, I think, from all of you about the different things that you heard about. OTF really values your feedback, and the link on the screen is actually active. You can click right on it, but I've also just put it in the chat to the feedback survey. Completed. It only takes a couple of minutes, and if you need a printed certificate for 48 hours after you complete the survey, you can print your certificate from that link. OTF winds up at the end of this month, so there's only about 7 or 8 sessions left, I think, maybe 9 or 10. But at that link on the screen and also in the chat, you can see what's coming up in the OTF world. We are meeting next week to start planning next year. So this is one of the things that the feedback surveys help us to do, is to decide what's going to happen next year. And you've heard this for those of you that have been here before, but we've got a lot of newcomers tonight. If you do take a math or technology AQ now or in the summer, there's a rebate of $450, which is a good chunk of your fees, from the Ministry of Education. So there's a website there that you can copy, and it'll take you to that information. So I'm going to stop the recording now.